Have you ever just stopped and thought about black holes? I mean, really thought about them. The idea that something out there is so powerful, so incredibly dense that even light can't escape. It's just, it's wild.
It really is. Definitely one of the universe's biggest head scratchers.
Exactly. And today, that's what we're diving into. We want to get to the heart of that mystery. What actually happens inside a black hole, and what role do they play out there in the cosmos?
Yeah, it's a fascinating topic.
Our mission here isn't just to see them as, giant vacuum cleaners in space. Our sources paint a much more complex picture engines of creation, destruction, all wrapped up in this huge enigma.
That's a great way to put it. They're far more dynamic than just passive objects.
So let's start with the edge, right? That boundary people always talk about, the point of no return.
Ah, yes. The event horizon, that's the crucial boundary. Think of it like, well, the ultimate one-way door in the universe.
One-way door, I like that.
Our sources really emphasize this, calling it the point of no return. And they mean it literally. Once something crosses that threshold, light, matter, anything.
It's just gone.
Pretty much. It's trapped. The gravitational pull is just too immense to overcome. There's no getting back out.
That phrase, point of no return, it's genuinely chilling when you think about it cosmically. But, okay, so if you do cross it, what's next? What are you actually falling into? What's beyond that horizon?
Right, that's the million-dollar question, isn't it? And that's where things get really, mind-bending. You're heading towards the singularity.
Singularity, okay. Is that like a surface, something solid?
Not exactly. It's not a place you hit, more like
a
point where our understanding of physics, space, and time just completely breaks down.
Breaks down? How so?
Well, according to general relativity, all the mass of the black hole gets crushed into an infinitely small, infinitely dense point. Imagine infinite gravity.
Infinite. Wow,
Yeah.
Okay. That's hard to picture.
It is. And honestly, that tells us more about the limits of our current theories than perhaps about the singularity itself. We suspect that to really know what's happening there, we need a new theory, something that connects gravity and quantum mechanics. It's like the ultimate frontier in physics,
So it sounds incredibly destructive, obliterating everything, infinite density, yet we keep hearing them called engines of creation. That feels contradictory.
It does seem like a paradox, doesn't it?
Yeah.
And it is, in a way. Yes, they absolutely consume matter and energy, but that very process, driven by their immense gravity, can also be a powerful creative or maybe organizing force.
How does that work? How can destruction lead to creation?
Think about the supermassive black hole sitting at the center of most galaxies, including our own Milky Way.
Right. Sagittarius A.
Exactly. As material swirls into them, it forms an incredibly hot, bright disk, an accretion disk. The energy and radiation pouring out from this disk can be immense. It can blow powerful winds out into the galaxy,
made of
hot gas, particles. And these winds can actually clear out regions of space, sometimes triggering star formation in one area by compressing gas or shutting it down in another by blowing the gas away entirely. They regulate the galaxy's growth.
So they're like cosmic gardeners in a weird way, pruning and shaping.
That's one way to think about it.
Yeah.
And sometimes they power quasars, these incredibly luminous objects, brighter than entire galaxies, fueled by matter falling into the black hole. These quasars can influence galaxy evolution across vast distances. So they're not just destroying, they're actively sculpting the universe.
Oh, okay, that makes more sense. They're dynamic players, not just endpoints. And it's not just about what they are now, but their whole existence, right? How they start, live, do they ever end?
Absolutely. Their entire life cycle is part of the story. We're going to explore that too, how they're born, how they grow, and maybe how they die.
Born from dying stars.
Some of them, yes. Stellar mass black holes are born from the collapse of truly massive stars in supernova explosions. Just boom, a black hole is left behind.
And the supermassive ones.
Their origins are still a bit more debated. But they likely started smaller and grew over billions of years, merging with other black holes swallowing gas and stars. A slow, steady accumulation at the heart of galaxies.
And death. Can a black hole actually die? I thought nothing escapes.
Well, that's where things get theoretical again, with ideas like Hawking radiation. The thinking is that due to quantum effects near the event horizon, black holes might very, very slowly leak particles back out into space.
Leak, so they evaporate.
Kind of, yeah, but incredibly slowly. We're talking timescales vastly longer than the current age of the universe. So it's not something we'd ever observe directly, but it suggests even black holes might not be truly eternal. It's a whole life story, from a violent birth to this almost impossibly gradual fade out.
It's just staggering. Black holes really are these deep cosmic mysteries, these powerhouses, and thinking that something so fundamentally destructive can also shape creation, it really shifts your perspective on the universe, doesn't it?
It absolutely does. It makes you wonder, what else is out there that works in these paradoxical ways? Despite everything we think we figured out, the universe clearly still holds so many secrets.
Keeps us curious, that's for sure.
Definitely. It's a reminder to keep asking questions about these incredible objects and really about the nature of reality itself. There's always more to uncover.